Okay, so we are still working with data sets, how to create this histogram. We're going to talk about how to make this frequency chart or how to read the frequency chart. We're about to do this class width. I'm going to teach you how to fill this thing in. Show you how to, this is just, where's my focus? This is just a blank that's, you can fill in with any sets of data. I'll show you, how to fill that in. I want to start by making sure that this is your list of vocabulary words. Be sure you've got these down. I mean, these vocabulary words, you need to, when you read them, you need to know exactly what they're talking about. You can't be a little shaky on these vocabulary words. You need to know the difference between frequency and relative frequency without having to think about it a lot. And what is cumulative frequency? What do they mean by tally? So these words need to be used interchanging and be used in context with each other or by themselves. Just be sure you have this vocabulary list. Okay, so my intent here is to give you this formula, okay? We're going to calculate the class width, and hope that I'm going to help you really understand what class width is. I'm probably going to overteach it. And for those of you who think I'm overteaching it, congratulations. Just, fast forward and get to the part to where you don't understand something. But it's really hard to move beyond this if you really don't get this. So let me overteach if that's what I want to do, okay? So here's a formula. I'm going to be using this formula. The formula for class width is you find the difference between the biggest number and the smallest number. And for those of you who don't know, that difference is called the range. You'll learn that, I think, in chapter 2, section 5. But that is the range, and you take that range, the range of your numbers, and you divide it by the number of classes that you have. And this is the part that messes everyone up. You always, always, always round up. I'm about to demonstrate that, okay? So we're going to come back to this data right here. We're going to create this, histogram on this piece of paper, okay? That's ultimately where we're going. But before we deal with this data set that has 51 pieces of data, I want to deal with a little bit smaller data set. So here's some numbers. I randomly just wrote some numbers down, okay? Now remember, all a histogram is when you take a set of data and you divide it up into sections. And it's like, putting toys in their little plastic bins. That's the way I want you to think about it. So in this case, I want you to take these numbers and I want you to put them in 2 bins. And the way you're going to figure out, and on a histogram, remember, this is the thing that I'm calling a bin, okay? So to model how we do that, the first thing I'm going to do is, we know we want a histogram with 2 bins, so I'm going to use that formula. This CW stands for class width, okay? I'm calculating the class width. The formula that I said a while ago, if you didn't write it down a while ago, pause the video, rewind it, go back and write it down. But it was the biggest number in the data set. My biggest number is 10, minus the smallest number in the data set. My smallest number is 1, divided by the number of bins, or the number of classes. Remember, I really need to be using this word because your textbook uses this word. So a histogram with just 2 classes, that means it's going to have 2 bars. I'm going to say biggest number minus smallest number divided by 2. Biggest number minus smallest number is 9. 9 divided by 2 is 4.5. I don't care if that's 4.5 or if it was 4.1 or if it was just 4. Whatever this answer is, you always round up. Always round up. So I'm going to have, so 5 is my class width. Okay, I've just calculated my class width. Now let me explain to you what that means. And this is the part, everybody can calculate 5. People don't have a problem calculating the class width. What they have a hard time doing is now using the class width correctly. Here's what that means. So if these are the bottom of my histogram bars, okay? Let's just pretend that these are my histogram bars. I don't know how many numbers are in this class. I don't know how many of these numbers are in this class because I've got to get the class limits. Okay, that's the next thing I'm about to figure out, my class limits. So the class limits are, hey, what numbers go in this bin and what numbers go in this bin? Those are class limits. Okay, class limits. I'm going to write the word right there, and then I'm going to point to them in just a second. Well, this first bin is always going to start, obviously, with the smallest number in your data set. So here's the number. I wish I could make it just stay focused. I don't know if there's a button. I don't know what did that do? Well, let's see if that'll make it stay focused. That may make it stay. Now it's kind of messed up. I'm sorry, y'all. Okay, so you always start, your first bin right here is always going to start with your smallest number. So it's going to be 1. Now watch what I'm going to do. The next number I'm going to find is the starting number for my next bin. And I find this number by taking the starting number here and adding my class width. So I say 1 plus my class width is 5. 1 plus 5. That means my next bin starts at 6. Okay? Now, I'm going to calculate all of these numbers right here are my class limits. I need to figure out, okay, well, if this is where my second bin starts, where does my first bin stop? Well, obviously, if the 6s and everything bigger than that are going to go in this box, then all the numbers between 1 and 5, including 1 and 5, are going to go in this box. Okay? Now, we figure out where this one stops by making this one the same size as this one. So we said 1, 2, 3, 4, 5. That's 6 numbers. So 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. You put 5 numbers in this box. You're going to put 6, 7, 8, 9, 10 in this box. Okay, so now I've just figured out my class limits. Let me show you how to do tally marks and how to do a frequency distribution. So the first thing you do, you write your class limits down. Okay, and your class limits are just exactly that. 1 to 5 goes in 1 bar. All of the numbers up here in this that are 1 to 5 are going to be counted over here. The rest of them are going to be counted over here. So my class limits are 1 to 5 and then 6 to 10. Notice that you should be able to add your class width right here. You can see this number right here is your class width. You should have it here and you should have it here. Okay? So there's where your class width goes. People want to put the class width right here. They want to say 1 plus 5 and put 6 right here, and then your bins end up being the wrong size. Okay, and now we're going to do tally. Okay, so all we do to do tally is we go through each number right here and you put a mark. Okay, so this number right here is a 5, so it's going to go in this bin. This number is a 5, so it goes in this bin. This number is a 5, it goes in this bin. This number is a 3, it goes in this bin. This number is a 5, it goes in this bin. This number is a 4, 2, 1. I'm on 6 right now. 6 goes in the second bin, so I put a mark down here. 8, 7, 4 goes back up here. 1, 1, 10, and 9. So 5, 10, 15, 16 numbers. And if I made this a frequency, so this is just a table showing tally marks. You can add to that table and put frequency over here, or you could have created a whole new table. The frequency here is just how many tally marks you have. That's 11, and this was 5. So we have 11 numbers in this bin, and we have 5 numbers in this bin. Now, here's what's happening. If we drew this out and you do a number line like you're supposed to, okay? On a number line, I'm going to have the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is a number line, and I'm supposed to have all the numbers on here, you know, evenly spaced, because that's what you do on a number line. You evenly space. It would be scaled. This is scaled by 1 because each mark represents 1 unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So over here on the y-axis, we have to scale the y-axis evenly, but the scale on the y-axis doesn't have to match the x-axis. So this might be, I don't know, this might be 5, and then this one right here could be 10. If you wanted to do 1, 2, 3, 4, 5, I'll show you on StatCrunch here in just a minute. Okay, so anyway, if we go up here right now and we put our bin starting at 1 and going over to 5, 1, 2, 3, 4, 5. Okay, and we go up to 5. Oh, no, we would have to go up to 10, sorry. Okay, that's how big that bar was. You'll have to pretend that's not there. Oh, wait a minute, I have some fancy white out. Okay. That bar looks like that, and then this bar starts at 6, and it goes over to 10, and it has 5 in it. Okay. So here is the way the histogram would look. Okay. And y'all are going, oh, that's easy. I got it. No, you don't. Because this is not a histogram. The reason this is not a histogram is because there's a space in between those two bars. And histogram says there should be no spaces. So what they do is they say, okay, well, we don't want any spaces, then we're just going to bump these little bars. We're just going to move them over. Instead of stopping at 5 and starting at 6, let's move it halfway in between. Well, what's halfway in between? Well, 5.5 is going to be halfway in between. So if I bump this one over here, and I go all the way to 5.5, and I start this one at 5.5, do the same thing on each of the other sides, because what I do to one side, I want to be sure and do to the other. Okay? Then I make my bars a little bit wider, and that keeps me from having a gap. Now, why do they say we can't have a gap? I have no idea. Nobody told me why histograms don't have gaps. They just said histograms don't have gaps. So that's the difference between class limits and class boundaries. The class boundaries for this histogram would be not 1, but we would have to back it up to 0.5. And we wouldn't be able to stop at 5. We would have to go over to 5.5. And then this one down here would start at 5.5, and it would go over to 10.5. So we just take 0.5 away from these two numbers because we back them up, and we add 5.5 over to these two numbers. And then the frequency is still 11 and 5. The boundaries, the limits that we had. Now notice these decimals are not going to matter at all. I'm about to run out of time. The things are not going to matter because we don't have any decimals up here. I'll finish and talk more about this here in just a second, but I'm going to go ahead and stop this video.